Hello, good morning.
Morning.
So, yeah, so let's wait for everybody to join the section and we will get started. So before we get started, any question? All right. So we're gonna do the demo for the Excel project number 3 first. And then after that, we'll do some coding from our studio, right? Based on what we learned so far. Okay. So let's first of all, let's go to Brightspace. Okay. Um, and let's go to Excel demo. And I want you guys to open the lab 3 practice. That's what we're gonna work with, right? Yeah. So let's open the file. It's a Excel file. Now we do some demo on the probability distribution, also the binomial probability distribution. Okay, let's download the file and open the spreadsheet. Okay, so let's look at the spreadsheet, right? So uh, let's start with the question 1. It's find the mean and standard deviation of x from the following probability distribution. So you need to find the mean and standard deviation. So the formula we are using, it's in the formula sheet. So if you go back to the course home and then open a formula sheet for syllabus textbook and formula sheet. And second one is the formula sheet. And let's just download this. On that. So in chapter 5, I will use several formulas, and the mean for the probability distribution basically is this formula, and the standard deviation is the second formula. And so we basically just use those 2 formulas, and also the third formula, right, for binomial probability distribution, which we're going to use for question 2 and 3. All right, so let's go back to the spreadsheet. Okay, so now I already create this column, third column and the fourth column. So for the third column, you just multiply this x value, which is discrete random variable, by the probability. Okay, get that, right? And then we just um, put a cursor on the bottom right-hand corner and then just drag it. We get the rest of the product. Also, we need to double check, make sure the total probability here sum up to 1. Okay, and it is 1. So this is definitely a probability distribution. And also this one, x squared times p of x, we could actually just do d4 times d4. X times x become x squared, and then times p of x. So that would be, yeah, it is. Oh no, times multiplying. And then let's just drag it out. So we get the rest of the uh, product as well. And then we need to sum up couple, right? Sum up this column here, we get the mean. Okay, 79.67. So the mean here should be this, E10. And then standard deviation, we need to sum up the fourth column. So the auto sum here, get that. Now the standard deviation is the square root of total of x squared times p of x, which is this number, minus mean square. And then you will get standard deviation. Okay. All right. Any question about this? Okay, so now let's look at question 2. So flip a coin 4 times. X represent the number of tails out of 4 trials. So discrete random variable here is the number of tails out of 4 trials. I find a probability using a binomial probability formula, but before we can use a formula, we need to check the conditions, 4 conditions. First of all, is a fixed number of trials. We have 4 trials. Outcomes in 2 categories, either head or tail, and the trials are independent. Right, all these trials, it's a fair coin, so trials are independent. Probability of head and tail remain constant. So P equal 0.5, Q equal 0.5. So now we can basically apply it, once we check that, we can apply the binomial formula. So BI dot EST from parentheses, and number of success is this X equals 0. That's for 0 success, 0 tail. That's what this means. And then number of trials, 4 trials, probability of success 0.5. And the last argument is false because we're looking at a probability density function. We cannot accumulate probability values, right? It's not possible for binomial distribution because it's discrete, not continuous.
Professor, before you
Yeah,
enter the
sure.
formula,
Mhm.
so you have the binomial distribution, the 4 is the amount of trials, the half is what exactly?
It's a probability of success.
Okay.
Probability of success, you see, if you click on that, first entry will be the number of success. Number underscore S means number of success. And then second entries, second number represents trials, number of trials, 4 trials. And the third entry is the probability of success.
Okay.
And then
Thank you.
also the last one, yeah, no problem. Okay. So it's either we are accumulating or we are not accumulating. So in this case, we're not accumulating, right? We are not accumulating, so it's false. Okay. And now once we enter one of this, then we can just drag it out, get the rest of them. Yes, it's symmetrical with respect to the center here is X equal to 2, meaning when we flip coin 4 times, on average, we expect to have 2 tails and 2 heads, most likely, right, with 37.5% of chance. And after that, we're gonna create a probability, we call this probability histogram, right? And then comment on the distribution and center. So now here, you're just gonna highlight all those entire table. Oh, before that, right? One quick thing is we need to sum up this probability, make sure it's 1. See, there's a total here. Let's check it. It should be 1, right? If it is 1, meaning it's good. Okay. All right. So now highlight the entire table, excluding the total, right? No need to include the total. And then insert, and then go to recommended chart. Now we're gonna pick the second option. Although they all look it's different, but the second option is the probability histogram. Right? So that we get that. And if you want to pick design on top, that's a design option here. I guess I pick this design this time, right? No, actually this one. Now we can actually customize this. So highlight one of the rectangle box. Now all 5 will be selected. And then go to format data series. And then change the gap width to 0%. And I'm going to also feed in the vary colors by point. And also on the border, I'm gonna pick a color, just make sure they are separated from each other. Here, and I'm gonna give a bigger transparency. Okay, and that should do it. And also I can put in the highlight those rectangle box, right click on it, and we can add data labels. Like we just put the all these probability values on top of it. Okay, and then this looks like a normal distribution, right? Approximate normal distribution. Also, I can change the title. It's called probability histogram. Yep. And also, let me see if it's feeding at the no at the trend line for my data series. Nope, I don't think that's available here, so no worries. We can just, if you want, you can just draw something, right? Right here. Actually, we could draw something like this. Yep. So looks like it's a normally distributed, approximate normal distribution. So we're going to comment on this. So I'm going to drag this on the side, and then I'm going to comment on this overall distribution. Also, the center, so comment. So the overall distribution is approximately normal distribution. And also the center, it's around, center is 2, right? It's around 2. With a probability value, with a probability value of 0.375, which is highest, right? Which is the highest probability. Okay, so that's basically how you comment on this overall distribution, also the center. Any question about this? And you can just, if you want, you can move it on the side. All right, then let's look at question 3. So you roll the dice 5 times and count the number of the times 2 showing up. And X represent the number of 2, right? Number of times, number of 2 showing up. Find the probability using the binomial probability formula. So again, binomial probability distribution, we have 5 trials here, right? 5 times, rolling the dice 5 times. Outcomes in 2 categories, either 2 or not 2. So having a 2 is a success event. Not having a 2 is a failure event. And all trials are independent. And then probability of getting 2 remain constant, okay. Which is 1/6. And then probability not having 2 is going to be 5/6. And now once we check all those 4 conditions, then this is indeed the probability distribution, binomial probability distribution. Then we can use a formula. First of all, we do binomial dash t, open parentheses, So number of success is this. Trials, 5 trials, probability success, 1/6. And then again, false. Last argument is always false for the binomial distribution. All right, and we hit enter. Okay. Then we're just gonna mimic all these formulas, okay, and then get a result, all these different probability values. Now sum up the total probability, we're supposed to get 1. If you get 1, that means it's good. All the work is good. And from here, we create a probability histogram as well. So go to insert, then again, recommended chart. And then we're gonna pick the first option. You can also scan through all charts, right? All these charts, different charts here. But usually Excel will recommend the most appropriate chart for us. And click on OK. Now this is totally different from the question 2. And first of all, let's do some modification. Here I pick another design, right? And again, click on this rectangle box, right click on it, and then format data series. Here, vary colors by point as well. And also reducing the gap width to 0%. Okay. And also for the borders, separate borders. 100% transparency. Let's see how that goes. And so I'm gonna use dark colors. Okay. So let's see. Okay, that should be good. All right. And then also we can add a data labels on top, but it's not, in this case, it's not because maybe we can change the amount of decimal places here down to 4. Yeah, a couple more. Okay. I mean, that's better, right? So then we feed it curve. It looks like it's very skewed to the right. So it's most of the probability values are concentrated on the first 3 outcomes, right? Meaning having a 0, 2, 1, 2, and a 2, 2, 2. And the rest of them are minimum, right? If you're adding the first 3 numbers, it's close to 96%. So meaning majority of the outcomes are concentrated from the first 3 results, right? Meaning getting 0, 2, 1, 2, or 2, 2. And again, this is a very, very skewed, right? The skew to the left. So the next common on this. And then if you look at the center, I would say center probably is around 1, right? Somewhere around 1. Now you can also verify that if you do n times p, 5 times 1/6, it's 5/6. That's kind of like a point A3, 0.83333, and that's pretty close to 1. Okay, so this is somewhere here, right? Somewhere here we have we get a center, right? So the distribution, overall distribution, is skew right, and center, it's around 1 with the highest probability. So will be 40.19% of chance having 0, 1, 2. That's basically what this is. So any question about this?
I actually have a question about the previous, just to
Mhm.
remind myself. Can
Mhm.
you go over the standard deviation formula one more time, please?
Uh, you mean question one, right, Caleb? Is that what
Yes.
you mean? Sure, sure. So right here, standard deviation is going to be, so you sum up this column here, x squared times p of x. So basically let me quickly show you, going back here, you see, this is the standard deviation formula. So we need to sum up x squared times p of x, right? And then minus mean square, and then taking the square root afterwards. So let's go back to this right here. So you do square root, and this is a total of E10 is a total of x squared times p of x. Right, get that? And then C12 here is the mean square. C12 is the mean. Now we square that.
Got it. Thank you.
Sure, no problem. Um, any other question? Okay, so and then your actual Excel project three, let's go back to Brightspace, and then let me point out to you, you can finish that maybe in 10, 15 minutes, and then we will start the demo, I mean coding demo. So go back to Excel project submission, click on that, and then you're going to open this one is due on uh, August 10th. So we open that and then open a spreadsheet. Okay, so let me just, yeah, open that. And it's opening right now. Go editing, then share the screen. Yeah, this one. Yeah, this is the project two. And again, first question, finding the mean and standard deviation of this. And the second one is, so 60% of high school students in the US using Khan Academy to review math contents. And then you pick four high school students, right? And you basically find the probability using binomial probability formula and then construct a probability histogram common on the distribution. And then the third one, similar, right? So suppose it's known that 10% of all orders get returned at a certain store each week. There are six orders in a given hour, then you create a binomial probability table first, and then construct a probability histogram and then comment on the distribution. So I guess I'll give you 15 minutes, right, to finish this. And then after you finish, we'll start the coding, right? We learn some coding using the RStudio. Okay, so now let me just put you guys in a breakout room. And if you have any question, you can talk to me on an individual basis. Right, so let me create a breakout room. All right, so let's resume, right? So from right now, let's take a look at the R coding, right? So first of all, I want you to go back to the Brightspace course. Okay. And then okay, let me just save this. Save draft. Two assignments. Yeah, let's go back to the course home. Now, when you scroll down, you see this. I create this link, install R and R Studio. So if you guys want to install the R and R Studio right now, or you already installed it, that'll be great. So you just click on this link. And first thing is to install the R. So R is kind of like a backend server, right? So all the important information is stored in the kernel. So R is kind of like backend server. Okay. And then we also have a front end, which is RStudio, right? So basically we code from the RStudio. So you download the R installers from this. So click on it, it will take you to the download link. So there are three different versions, right? Download R for Linux if you like to code in Linux, or download R from Mac OS if you're using Mac. So you download that. If you're using Windows, you download the third option, right? So let's say I'm using Windows, so I'm going to download this, and then you scroll down. You should have this R for Windows. Install R for the first time. You see here. So you just click on that, and you can download the this is the most updated version of the R. And once you download this, then you can do the instant like updates, right? They will remind you to update it when they come out with a new version. And again, R is the open source software, right? Meaning it's free, so basically anybody can use it. That's a pretty nice feature, right? And so this is how you download the R, right? Also, you need to download R Studio. So go back to the previous link. And if you scroll down, right, this right here, scroll down, you will be able to get to install the R Studio. Okay. And again, right here in the middle section, and then click on this download R Studio. I need to download both, right? You need a backend server and then front end interface in order to code. So definitely you need both. So, and then there's a Windows, Mac OS, right? Mac, Ubuntu, that's for the developers, right? If you are developers, then you use those, yeah. But Mac and Windows is good enough, right? So if you have Windows, you just click on that, and then it just tell you to run this program. And once you successfully run the program, yeah, so it's might end, it's downloading right now, right? You just once it's completing downloading, just run it, right? Run this app and be installed to your desktop or laptop. Once you do that, and then we could basically start this coding, right? So I'm gonna open the RStudio here. So you just go to the search bar, type in RStudio. Okay, and then you see this. And all right, so this, let me just share the screen with you guys. Share, yeah, RStudio. And again, this is RStudio, which is a front end. This is a coding platform. Also, it's a typical interface. You know, we have different kind of like. So I'm gonna just close all this. This is a time series analysis. We don't need that. So this is a typical interface. That's three blocks, right? First block usually is here, and this is where we type in the code, right? Let's say this is where we just install, let's say, packages. All right, and let's say install packages. So there are a lot of different packages in RStudio. ggplot2 is one of them, right? If you, let's say I just do something, install that. Nope, I don't want to restart the R. Okay, nope. All right, so you just install the ggplot2. That's a very powerful package to do data visualization or like get a first impression about the data set. So this is where we code, right? So this is where we type in the code, and then execute all the codes. And also on the top, I'm going to show you some of these new files, everything is still loading. So that I'm going to wait until finish loading the package ggplot2. And then on this side, on this block, this is environment, and then history is the code I use, right? From the previous section, and then all the files, all the files here, and then you can look up all the codes, to use, right? You used from the previous sections, and then down below here, and then we can also resize this, right? You can actually just drag it and resize it, and then all different packages are. So also we can just resize this. We can just resize. And this is all the packages, like a lot of different packages. And if let's say you want to install it, and then you just do ggplot2, right? You can also install the package from here, right? Just install, and then this is installed from the package repository, which is CRAN, right? Repository. That's where we install in the backend. That's where they store all the packages. Okay. Yeah. And then you just click on install, then you'll be able to install any package you want to install. Okay. And also there's updates, there's updated, packages. So people are constantly working on this, improving all the code, the packages. And also help here, under the help, let's go back. You can type in let's say dataset MPG, right? And then search for it. And basically, if you type in the dataset MPG here, they will provide the description of the dataset. This is fuel economy data from 1999 to 2008 for 38 popular models of cars. And that's a EPA's, they actually resort to the EPA standards, right? Meaning they have to use EPA standards to guide their production. Yeah. And then in this data set, there's different kind of like variables. The first one is a manufacturer, model, displacement, year, cylinder, transmission. DRV is the type of drivetrain, right? Front wheel drive, rear wheel drive, or four wheel drive. So this is a categorical data. Transmission, I think, is also categorical. Number cylinder is also categorical. Right? The 4 cylinder, 6 cylinders, or like 8 cylinders. CTY, that's the city miles per gallon, right? This is how many miles per gallon does this car get in the city? And there's a highway miles per gallon, right? This is how many miles per gallon does this car run on the highway? And then fuel type is either diesel or like regular fuel, and then classes type of the car. It's either SUV or like compact car or like truck. Okay, something like that, right? So you can actually search for any like topic, right? Any data set, embedded data set in the studio. Okay. So now let me just adjust this. Yeah, I think we don't need this history and also plot, right? If you do any plot, you usually show up here. Right. Now, next thing, since it's the ggplot2 has been loaded, so I'm gonna go to file. Okay. Code. For some reason, it's not, all these options are not here. Let me see why does that happen. Let's see. So, okay, it's completely low. So I already got a set. Um, Mm, And let me see that. Let me run a quick code on hat, right? MPG. And this is the MPG is the data set we're looking at, we're working with today, right? So let's do a quick hat. And then it just basically shows us the first 6 rows of this data set. So we get a manufacturer, Audi, it's model A4, displacement, which 1.8 liters, and year is 1999, right? And also, they have 2008 model, and then it's from 1999 to 2008 for 38 popular models of the car. 4-cylinder, there's a 6-cylinder here. That's auto, there's a manual. A lot of old cars, some of them have a manual option. Even nowadays, they put back the manual option. So that's and all of these are front wheel drive, right? F means front wheel drive. And the city mileage is 18 miles, 21 miles, 20, 21, 8, 16, and 18. Right. So that basically give us all the things missing couple. Three more variables. See, it says highway and then class. Okay. Yeah, I guess it's okay. But all right, maybe let me just close out this, right? I'm gonna close out this for a second. I'm not gonna save it. All right. One more time, I'm gonna go back to I'm gonna open the RStudio. Maybe because I'm working on something earlier, so um it wasn't saved or something. Okay. And this is okay. And then it should let me share the screen first. Yeah, so this is the typical ones, right? And then it's asking me to like install the updates. So there's a new updates available here, newer version here. But no, I'm not gonna do that. I'm just gonna remind later. Okay. So this is a typical interface again. And typically here, right? Once you open it properly, like when I just did, there's new files, right? We can pick different files here. And then one of the most popular ones is R Markdown. Okay, R Markdown file. And here, let's tell you, I'm gonna give a name, right? Introduction to R. And actually it has an author here and then the date, right? By default, they put on the author. If you create this document, you are the author. And you can pick a option here that say you want to save it as HTML or PDF file. So I'm going to save it as a PDF file, right? So you have options, 3 different options. Okay. Use current date when rendering documents. Okay. No, you don't have to do that, right? If you don't want to put in a date, it's okay. And then click on OK, right? So now the R Markdown file will come up, right? Right here. And also in the R Markdown file, okay, so I'm gonna just get rid of this. I'm gonna get rid of all these unnecessary lines. Okay. So this title, date, everything is output is gonna be PDF file here. I'm also gonna save this file. I'm gonna save under downloads. I'm gonna call that introduction to it will save as an RMD file by default, an RMD file, and click on save. Now, let's start with some analysis, right? And then also, maybe before that. So there's a lot of different kind of options here. You can do save, right? Save as, okay, in the new project, you need to save it, but you work on actual project, you want to save it. And also, if you need to import data set, let's say from the Excel, from SPSS, SAS, Stata, or like CSV file. The first one is a CSV file for text or base is a CSV file. And that's a very popular form of the data files. Okay. So then, edit, right? So we can go back, right? We can undo something, redo something, cut, paste, pre-sender, and also code, right? Just like coding block for the coding blocks. You can insert trunk, jump to, all those different options. But yeah, if you need it, you just go back here and then use it. And that's different views. Let's say you want to zoom in a little bit, right? You can zoom in, make it larger on size. And also you can resize this, right? And then under plot section, and that's also a set working directories to source file location, load workspace. You can also restart R, restart R and then clear outputs, restart R and then run all trunks, meaning running all the coding blocks. And that's optional debug. If there's a bug in your code, then you can debug. Okay. Profile tools, different tools here, and then there's a global. One more time, let me show you how to get to this. Maybe let's just cancel that a little bit, right? So we go to tools and then go down to global options. And then basically you can change the display and then interface of your R Markdown, like appearance. You can change different, like you can change different style, sky and June 175. I'm going to do 150, then you see this. And the editor thing, right? The different things you can pick, ambience. It's just a DOM, different. You can just pick the one you like, right? This is where you can customize your coding interface tomorrow. Okay, I think tomorrow night. I pick tomorrow, I guess. Yeah. And then apply and then click on OK, right? It'll be implemented into your section, right? So now you see my interface changed slightly. And also on the help, this is also pretty helpful. And that's our help. If you type in a topic, let's say, just want to take a look at histograms, hit enter, basically histogram and kernel density plot, right? Will give us a density plot, histograms, like the complete structure of the histogram code. Right? This is a complete structure. But a lot of different kind of arguments here, we can do, right? Right. So basically, you can look into that if you are interested in certain topics, right? In the statistical analysis of data science, you can search it here under help. There's a cheat sheet here, for R Markdown cheat sheet, right? If you click on that, it will take you to this. It will give you a sheet. It's R Markdown sheet. Let me just go back a little bit. This is the PDF file. Then here has all the information like how to edit R Markdown files. Okay, with different options here. That's also you can look into that if you're interested in this. And you can use R Markdown to create a very professional document and publish your work, right? If you necessary. Yeah. All right, so let's go back to RStudio one more time. And then also there's under cheat sheet, there's R Markdown reference guide, right? That's also pretty useful. And then you see there's an RStudio IDE cheat sheet, data transformation with dplyr, data visualization with the ggplot. Maybe let's look at that. But again, that's another document here. You open it, it'll give you a whole bunch of different kind of like give you some details or like overall guidance, on how to use that ggplot2 package. I see graphical primitives. Depends on what kind of the graph we try to create. Maybe let's say you want to create a polygon, right? Polygon, and then you use the argument right here. If you want to create quantile plot, right? This is the argument under this block here. And Geon smooth, right? Like how to smooth out your graph. Yeah. And then Geon lines, how to create a line graph. And then hex densities, Geon density, bind to D, right? 2D graph. Okay. And all those different like box plots, right? It's very popular ones. And then dot plot, violin, right? We can create a violin plot and then using the ggplot2 package. Again, look into this. Let's say you need to custom design, right? Design certain graphs, and you can use this like cheat sheet to create some special graphs. Okay, so this is another one, and go back to RStudio. Okay. Then again, under help, there's another cheat sheet. It's Armadan reference guide. I'm also going to show you that. And this is it will guide you to a website, turn data science into business impact. And a lot of companies, using this platform as well, right? Or like sponsored of this. You see different names, Walmart, Johnson Johnson, Pfizer, all those different companies, Carfax, okay. And data science code editors, Human Drive, okay. And so yeah, so that's kind of like a external, resources, right? For the for this R code. Okay. Now let's go back to RStudio and let's start. I use this to code. I'm going to code it under this Armadan, right? Under this Armadan. So first of all, we're gonna let us analyze the MPG data set. So this data set, if you want, you can just type the MPG one more time, click on that, and then it'll give us the description of MPG data set. And this is what they call an embedded data set, meaning it's already embedded in RStudio, so we can use it, which we can just use it directly. Okay, MPG data set. And we're going to look at the measure of the center and the variations. Measure center and the variations. Now here, so this is kind of like a title, right? And let me show you, if you need it, like if I need it to HTML file, basically you just ask you will run will give us kind of like a quick document, right? Like what it looks like, right? Actually, when I need it, it looks like this. Introduction to my name and then date. And then that's a title here, right? We're gonna analyze this MPG data set. Okay, this is kind of like you can constantly checking the progress of this document. Okay. I'm gonna close out that, and then here I can actually minimize, this console, right? This is called a console. We are coding using R Markdown, right? Okay. So now, in order to code, you need to get a coding block. So type this, recall 3 times, curly bracket, then putting R, right? This indicates we are getting the R coding block. Now from here, we can type in the code. Let's say library. Want to need a data set, right? Embedded data set. So library data sets. And also library, we're going to use ggplot2 package, ggplot2. Okay. So yeah, so that's a couple things we need. And then also I'm going to type in add of the MPG data set. Now I guess I will close out this coding block for a second. So recall 3 times on, meaning we are closing this coding block. Now we can run the code right here. Okay. You see, run current trunk. So I'm gonna just run it. Okay. And then you see, then basically right below it, you're gonna see the outputs. Okay, so this is much more nicer, right, compared to the other platform. You see, it shows us first 6 rows and all the variables here, right? Like city mileage, highway mileage, and different classes, compact cars, all that. Right? And it's basically to show us everything. Okay. It displays the 6 by 11, right? The table means 6 rows, 11 variables. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 11 variables. Right? Yeah, so and then also if you don't want to see these outputs, just close out that. And below it, so right here, now I'm going to put in more outputs. So I'm going to again get in the coding block, open curly wave, putting R, meaning we are putting R code here. And then I'm going to do summary of MPG dataset. And also we will do mean. Maybe we'll do it later, right? So let's get summary first. I'm going to close the coding block, recall 3 times. Now let's take a look at summary of MPG dataset. So click on run current trunk. Now you see, it basically gives us a description of each variable, like manufacturer, classes, character, meaning different manufacturer, right? So it's character. And then model is also character, right? Like Audi A4, that's a typical model, is character. Displacement, once it's numerical, right? If it is numerical data, and RStudio will show us the 5 number summaries, like minimum Q1, first Q quartile, right? Means Q1, 2.4, median, that's Q2. Also show us the mean. Okay, that's a slight skewness here, right? Because mean and median are not close, right? There's a slight difference between the mean and median. And also quartile 3, it's 4.6, maximum is 7. And also under the year, right? Minimum is 1999, maximum is 2008. So then median is 2004. Q1 is 1999, Q3, 2008. Okay. And cylinders, that's just 4-cylinder, 6-cylinder, and then 8 cylinders, right? Those are the typical settings. Transmission is also character, right? It's either manual or automatic. And DRV, that's also character. If you want to see what each variable represents, you can look into that. DRV is a type of drivetrain, either front wheel drive, rear wheel drive, or 4-wheel drive. And CTY, that's city miles per gallon. Right. So minimum is 9 miles per gallon. Q1 is 14 miles per gallon. Median is 17 miles. And mean is 16.86. And then quartile 3, that's 19 miles. Maximum is 35 miles per gallon. Highway minimum 12, Q1 18, median Q2 24, mean 23.44. So this one, they are close, right? The mean and median are closer. So meaning it's probably a normally distributed data set for the highway mileage. The maximum is 44. Okay. And then FL is fuel type, right? So it's also character. But we can also define this as a categorical, right, for the fuel type. And a class is type of car. We can also define this. We can also convert this to a categorical variable in this case. All right. So that's it. Sure. The question?
I'm not able to see the your screen. Are you sharing your screen?
Yeah, you're not seeing my screen? How about now?
No.
Are you able to see it right now?
No.
No?
Carla, there are two tabs in Zoom, so it's possible
Mhm.
you may have to switch over to the one that says Adam Lee's screen at the top.
Yeah, very
Right.
good.
Now I can say thank you.
Yep.
Yeah. And very good. Thanks. I didn't realize, there's two tab on your end. So I was a little, shocked, you guys not seeing my screen for such a long time, but yeah, okay. So this is basically, and also I'm gonna just close out this, right? We're gonna look into some more, summary statistics. So now, yeah, I'm gonna get a new coding blocks. Okay, so one more time, recall 3 times, curly bracket R, then I'm gonna put in something, right? Then say mean. Then we're gonna find out the average for this MPG data set and dollar sign here indicating we are looking to a certain variable here. Once you have a dollar sign, and in this case, we'll take a look at the city mileage, CTY. Right? CTY is a city miles per gallon. And also we're going to do a median. Let's get all the summary statistics since we already learned all of this. PG dollar sign, CTY. And also we'll do variance, VAR. VAR means variance. We'll find the variance for MPG dataset or CTY. Okay. And then also the standard deviation, SD, MPG, dollar sign, CTY. Okay. Get a standard deviation. So I'll get the interquartile range, IQR, right? Interquartile range. Q3 minus Q1. Same with the same variable, CTY. And minimum, mean, MPG, dollar sign, CTY, max, MPG, dollar sign, CTY. And also range. One last thing is range. This is all we learned so far, right? In chapter 3, MPG, dollar sign, CTY. Then once we finish all the codes, and I'll just recall 3 times. Then let's run all this code. Okay. And it's successfully run. So the first outputs here is mean is 16.85897, median is 17, variance is um, variance is 18.11307. Standard deviation, it's 4.255946. And also interquartile range, right? That's going to be 5. Minimum, it's 9. Maximum is 35. Range is between 9 and 35. So the range is 26. So that's basically all the summary statistics. I guess let's take a break, right? Let's take a 20 minutes break. When we come back, we continue the R code demonstration. Okay. We
Prof.
left
Chester,
off. Mhm. Yeah.
you didn't call my name, but I'm here.
Okay. I think. Hey, yeah, Justin, I marked you. Yeah,
Thank you.
I saw you. Yeah. Okay. Let's go back to the R studio. Okay, let's continue right where we left off. So now let's look at create a histogram, right, based on the CTU, based on this variable. So I'm gonna clear this output. It's right here. Let's clear the outputs. Okay. Now here, next thing I will create a histogram. Based on CTY. This variable based on CTY. City mileage. Okay. And again, I'm gonna get a coding block recall 3 times, curly brackets R, and I'm gonna do a very simple graph, right? Hist means histogram, and then just specify it's gonna be CTY, city mileage. And also I'm gonna create a. So let's look at this one first, right? So I'm close the coding block. Now I'm gonna run the code. And as you can see, yep, so this is the very raw graph. We get a histogram of a PG data set. The variable we're looking at is CTY. And if you look at this, that's a slight skewness, right? If you fit in a, we say this is slightly skewed to the right. And the center is probably somewhere around 15, right? Somewhere around 15 right here. So this is what we see from the first histogram. So now here I'm gonna put in a little bit more sophisticated arguments, putting more arguments. So MPG, $ CTY. And then here I'm gonna specify the XLab. I'm gonna give a title for x-axis, put a double quotation mark, call this miles per gallon. You can say open parentheses city, close parentheses, and then YLab, it's a frequencies. Frequency means number of cars in each class. And also give a main title here, histogram of MPG of CTY, I guess. And then I'm gonna breaks here means we want 12 classes. I say I put in 12 classes. Breaks means 12 classes. And then color, I put in outer blue. Let's type over here, outer blue. Once you type in a color, then you give you a sample color, right on the name of the color. And also the border, for different color for border, I'll say dark orange. Or any color you like, right? As long as they separate properly. Now, one more time, I'm gonna run this current chunk of the code. All right, so let's see, the first graph is here, and the second graph, if you click on it, this is the second graph, and it's slightly better, right? And then again, this overall trend looks slightly more clear. It's just skewed to the right. And then the center again is somewhere around 15. Okay, that's for sure, right? Somewhere here. And so basically you can put in more arguments, right, in this particular graph, and give us a better graph, all of this. So, and if you want to comment this, I'm gonna just close out this. Let's say you want to comment on this result, you can say comment. So based on the histogram, data set is slightly skewed to the right. The center 115. 15 miles per gallon. So that's basically what we see from this histogram. Now let's create some other graph, right? So we're gonna create a bar bar graphs based on another variable called DRV. If you look at the DRV, actually is a different type of the drivetrains, right? Front wheel drive, rear wheel drive, and four wheel drive. And again, the title create the bar graph, bar plot based on the variable DRV. Okay, recall 3 times, getting a coding block. Now we're going to do bar plot. And same, right now. I'm going to create this table. MPG $CT1. I mean DRV. That's the variable we're looking at this time. And also, I'm going to create a graph. Bar plot table. MPG $DRV. And here I'm putting more arguments like XLab. Is drivetrain, so different kind of drivetrain. And 3 of them. First one is F means front wheel drive, FWD. And R means rear wheel drive. And then 4 means four wheel drive. And then this is the XLab, X-axis. Now Y-lab it's frequencies. And then the main title is going to be drivetrains. And the color, just pick color you like. Let's say purple. And then the borders. I use dark green. Okay. Now close the coding block, recall 3 times. Then after that, let's run this block. And the first graph, we get this. So we have if you look at frequencies here, right? Four-wheel drive is about 102 cars, right? Front-wheel drive, maybe 105 cars. And a rear-wheel drive, it's maybe 20 something, right? 22, 23, something like that. If you look at the second graph, just with more details. Okay. It's graph more data. It's right here. So I'm going to put in missing a parentheses here. We run it. Okay, so this is just kind of like it's the categorical variable, right? That's why it's called bar graph or bar plot. Okay. The next thing, let's create a box plot based on the CT1. So I'm going to close out this output. Okay, close it out. Now create the box plot based on CT1, city mileage. Now we're going to get a green block, recall 3 times, curly bracket R, and then box plot. Let's create a raw ones box plot. MPG $CTY. Okay. And then let's close coding block. And then let's run the current code. Now get the first graph, and then based on this graph, you see that there are 4 outliers. Okay. So on the high side, right? There are 4 outliers. The minimum is around 9. Q1 is probably somewhere around 14. Then Q2 median maybe around 18 or 19. Median probably is 18, right? And then Q3, that's 19. And then the maximum, the common usual maximum should be 26, but we get some outliers here. This is probably 27, 28, and then we get 30, 33, and 34, right? Somewhere like that. Again, that's outliers. So this is kind of like modified box plot, right? So, and then one more time, if you want to give more details on the box plot, we could do this. There's another way of creating box plot. Right? Box plot and CTY curly wave and DRV. And data is MPG. See what this looks like. Okay. And this is the second one, right? So we are plotting this DRV front wheel drive, rear wheel drive, and the four wheel drive, and generating the box plot for each category. So you see, so the second graph look like this. So as you can see, for the four wheel drive, looks like there's a little, it's probably close to normal distribution, somewhere, close to normal distribution with outliers, one outlier here, based on a modified box plot, around 21. And then for front wheel drive, has a skewness, right? It's a skew to the right, right? It's a little skew to the right because we have a longer right tail here, and then with 5 different outliers. And for rear wheel drive, I think this is probably skew. You see, median and then the Q3 are almost the same, right? Almost identical. So meaning there's a heavy skewness and the skew to the left, right? Very skew to the left. So all three different categories actually behave differently. Also, let's say this you want to put in more features for this box plot. Now actually we can just copy this. And then I'm going to put in a little bit more arguments here. I'm going to put in XLab equal drivetrain. And F means front wheel drive. R means rear wheel drive. And then full means four wheel drive. Close parentheses, that's X axis, title for the X axis, Y axis. It's going to be frequencies. And also the main title. It's going to be drivetrains. And then the color, SM light blue. And then the border, it's going to be dark orange. And, one more time, again, this one just have a little bit more details. And we're going to get third graph right here, right? If you click on it, scroll down, you see just a little bit better contrast. Right? So we can focus on the distribution the center. Yeah, so basically same graph, but just different, different display, that's all. And yeah, so that's box plot. And then also we can create a scatter plot, right? So I'm gonna just clear out outputs. So next thing, let's take a look at the scatter plot, create a scatter plot. To examine the relationship between two variables. It's called scatter plot. based on displacement, SPL. Displacement, if you scroll up a little bit, you see it's engine displacement in liters. Okay. So it's different kind of like displacement. Now, again, get coding block, curly wave R. And let's plot, right? Just simple plot will give us, so it's CTY. So we are trying to figure out relationship between the city mileage per gallon with the displacement, according to displacement. Data is MPG data set. Now close coding block, recall 3 times. Now let's run the code. You see, so this is basically based on different displacement. City mileage changes accordingly. And we have 2 liters, 3 liters, 1.8, right? 1.8 here. 4 liters, 5, 6, and the highest will be 7 liters. And that's highest, right? And then if you look at it as the displacement increases, I think city miles per gallon decreases. So the overall trend is decreasing, right? Downward trend, meaning as displacement increases, then CTY decreases. And if you look at it, there's a couple outliers here, right? These 2 will be considered as outliers. Maybe this one, right? This one could be, so our best VD line probably somewhere here. This probably is outlier 2, right? These 2. This one definitely, and those 2 for sure, right? That's some outliers here. But the overall trend, right? So if you want to comment on this, as the displacement increases, then the CTY, which is city miles per gallon, decreases. And this is what we see from the this plot. Now let's just put in more arguments right here, down below that. I'm just copy this, and I just I'm putting more arguments. So like put in the title here, XLab. It's gonna be the engine displacement in liters. So parentheses here. Also the YLab is going to be miles, gallon, city. And then the main title, it's MPG city versus engine displacement. And I'm gonna put in PCH. It's we put 20. If you want to know what is PCH, actually it's not this. Okay, it's gonna be the size of the circle, right? We see from the scatter plot, and the CX is the style. So one is a circle, color, just give a light green. So that's our specification on this scatter plot. Now let's rerun it. Run the current trunk. Now you see we get a second graph. That's what we want. Okay, and Again, same patterns, no major differences, just change, I have a title right now, x-axis, y-axis, now also the main title here. Also, still the trend remains the same as the displacement increases and the city mileage decreases. No major difference. Okay. And next thing we will take a look at some of the basic graphs, right? So like we can plot some functions, right? Some math functions and calculate probability values for normal distribution. Maybe we'll do that later. So let's just plot some basic math functions first. Okay. And then recall 3 times for the wave R. I'll start with the plot cosine functions. You can plot any function, just put in COS means cosine x, and then we plotting one cycle 0 to pi, 2 pi times 2 pi, right? And okay, let's close coding block. And then also, I'm also going to plot tangent. So from minus pi to pi. And also I'm going to plot exponent with base e, so exp, from -3 to 3. X value from -3 to 3. And also I'm going to plot normal density functions, normal standard normal distributions. DNORM means it's a normal standard normal distribution with a z-score from -3 to 3. Also, I'm going to plot normal density functions. And now still -3 to 3. Now I'm going to put in more details. Colors light, red. Let me just write. LWD, thickness of the font 10. And main title, call this standard normal distribution. And then XLab, x-axis is the z-scores. The y-axis, that is density, the probability values, right? Density means probability values. You can also say probability. So I'm going to close the coding block. Now here we are plotting 5 things, right? 5 different functions. So the first function is the cosine from 0 to 2 pi. Okay, that's what it looks like. And the second function is tangent, right? And it's from -pi to pi. Okay, that's what a tangent graph look like. And then third one is exponent with base e from -3 to 3. Okay. It's increasing, right? From left to right. And then the fourth one is the normal density curve, or like standard normal curve from, so x-axis is z-score, okay, z-score from -3 to 3. And then also the last graph, I think, is slightly better, right? Okay, I think that it's too thick, right? So we can change the LWD, right? Thickness maybe to just a little bit too thick. So I'm just change to 6, see what happens. I think it's slightly better, but if you change it to 2, I think it's probably better, right? So yeah, so this one is better with the title here, z-scores, and on the y values, probability values, and this is a standard normal distribution. Okay, from -3 standard deviation to 3 standard deviation. Okay, so you look at the outputs and then you can adjust accordingly. Like if let's say you want to throw in more features or something like that. Okay. And so we can apply a lot of different things, right? A lot of different functions according to this. All right, so I'm going to clear out the graph. Okay. Now we're going to do some more. We can take a look at binomial distribution, right? That's see how you calculate the probability, the probability values. For binomial distribution, for the binomial. So let me give you a context. Let's say a bank knows that historically 1.2% of transactions in a certain category are fraudulent. The bankers, right? Let's say personal bankers monitor 500 random transaction today. And the first thing is what is the probability that what's the chance of seeing or detecting, let's say, exactly 5 fraudulent transactions. Okay. All right. So this is how you do it, right? It's slightly different from the Excel. So again, get a coding block, and then it will be D, meaning density. Density meaning not accumulating binomial, BI, NON, binomial, right? D binomial, open parentheses, and putting X value 5, and then the size is a sample size 500, and then probability success, pretty bad. BT equal to probability of success is 1012. Post a coding block. Okay. And then that should do it, right? That will give us the probability values, right? It's 0.1612. If you go back to the Excel, we should get the same thing, right? Based on this. X equal 5, N 500, probability 0.012. I'll just copy these numbers and go back to the Excel. So let's just open new sheet and paste this, right? So it's going to be binomial distribution. Number of success is 5, trials 500, the success 0.012, and then not accumulating, of course. We get the same result, 0.16127. That's exactly what we have on our studio. Okay. 0.16127. Okay. So that's how you do the exactly 5 fraudulent transactions, right? Number of success 5. And it's pretty high. I mean, the chances, it's likely, right? Having 5 transactions. But if you want to, if let's say you put in, I'm going to clear out the outputs. I'm going to check the other one, right? Let's say, what is 50 fraudulent? Let's see if that is possible. Like, what chance is that? Now again, get a coding block. And the same formula, right? I'm just copy this code. The only thing we have to do is change the 5 to 50 and close curly block, and then we're going to see the probability values. And this is very low, right? It's 9.2 times 10 to 30 power. So this is almost like impossible. Yeah. It's harder than winning the lottery, right? This chance is lower than winning the New York Mega Ball, right? Oh, like Mega Million. This is even lower than that. So this is not possible. It's impossible, right? Almost impossible event. All right. So chance is very low. So I'm going to close out this output. Now the third thing, let's look at this. We're gonna, what is the chance? What's the probability? What's the chance of seeing, of detecting at least 10 fraudulent transactions? Now 10, at least 10 means 10, 11, 12, 13, 14, 15, all the way down to 500, right? But that's not how we're going to do it. So we're going to use 1 minus at least 10. Okay. So this is easier, much easier if you do using 1 minus. So our idea is we do probability of at least 10 means we do 1 minus probability of the complement, right? Which is P from 0 to 9. Okay. So actually 0 to 10, right? At least 10, so 10 and above, right? So 0 to 10. Meaning 0 fraudulent transaction all the way to 10 fraudulent transactions. So you add up those probabilities. So this is a lot easier, right? Doing this way.
Should it be 0 to 9?
10, because at least 10 means 10 and 11. No, actually, at least 10 means, oh,
You want to include 10, right?
all
in
right,
your
include 10,
probability.
yeah. So that's 0 to 9, that's right. Yeah. Exactly. Yeah, so, and we do this, right? So we do 1 minus P binomial, right? So P indicates we are adding the previous 10 outcomes, like 0 fraudulent, or 1, 2, 3, 4, 5, 6, 7, 8, all the way to 9. Okay. So this is kind of like adding all these 10 different probabilities, right? If you do P means D will be density, meaning it will be just like the other argument. Force means we only find a probability density function at that given moment. But this one, we are adding the previous 10 result, 10 probability values. So here we just putting 9, and also size is going to be 500, and also probability is 0.012. And that will do it. Let's yeah, close the coding block and let's run the code. And this is the probability values. It's just going to be 8.27% approximately. So meaning the first 10. So if you just do this, let's run this. Right? This one should have much. So it will be the complement if you look into that, right? It's 0.91. So the first 10 transactions, first 10 outcomes actually has a majority of the data values, right? About 91.7% of the outcomes belong to the first 10 outputs. So now maybe let me give you an example. You guys can try this, right? Let's say try. You send a promotional email to 1,000 subscribers. historical data. It was 3.8% click-through rate. Meaning somebody will click on your link and say it's a YouTuber, and then you have 1,000 subscribers. You send an email to those 1,000 subscribers. 3.8% of them will click on your link. This is what this means. Now you want to try a couple of things. What is probability? What is probability at least 50 clicks? At least 50 clicks. Second one, what is the probability of exactly 40 clicks? Yep. So give it a try, right? Probability. Maybe a couple minutes. Try that. I'm going to just quickly show you. This is what we get so far, right? So this is you see it's a codes, in a proper and an output. This HTML files. As you can see, this is pretty, nice, right? Pretty nice, outputs. Yeah. Yeah. Also, you see all the comments are, you see, based on this histogram comment based on histogram. That is, yeah. All right. Let's go back. Now, yeah. So whatever we did in the Markdown file is also presented in the console, right? If you look at the console, just enlarge the console, you see all this code we typed in the R Markdown. It's also showing up in the console. Okay, so it's kind of concurrent, right? Like they actually move in the same. They actually ask you at the same time. Okay. All right, so I'm going to minimize this. Okay. Let's go back. Let's just take a look at the outputs here. First of all, here is 1 minus p binomial, and then the number of successes up to 40 now, right? at least 50, so it will be 1 to 49. So accumulating the first 50 outputs, the size is 1,000. Sample size 1,000. Or like number of trials, 1,000 trials. Our success is 0.038. And that's A, right? Then part B will be density binomial. We want to find out 40 clicks. Its size is 1,000. VT value is going to be 0.038. All right, and then that should do it. And let's just run the code really quickly. I see it's a for the first one at least 50 at least 50 clicks. It's very low chance, right? It's 3.26% of chance. But for the probably exactly 40 clicks, it's a lot better, right? It's about 6%, 6.089%, which is twice as likely, right? Twice as the at least 50 clicks. That's how we get binomial. The next thing we're gonna look at the iris data set, right? So let's take a look at iris. So if you on the search bar here, you type in iris. Okay, and then basically you will see the description of iris data set. It's Egger-Anderson's iris data set. Gives the measurement of in centimeters of the variable sepal length, and then with sepal width, petal length, petal width, respectively, for 50 flowers from each of 3 species of iris. There are Setosa, versicolor, and virginica, 3 different species. That's the name of the species. And the format is 100 data frame, meaning the data set is 150 case, 150 rows, and 5 columns, like 5 variables. And right, and then there's the sample code right on the iris data set. Okay, that's basically the description of the iris data set. All right, so let's just run some analysis, right? Let's run some analysis. Iris data set. Okay, so let's start with the plotting iris. If you just do quick plot iris, you're gonna see like correlation matrix plot. You simply type in plot iris, you see this. So you're gonna see a lot of different graphs, right? Like, and then it's based on different kind of like here it's a sepal length. This first row is sepal length. This is sepal width, and then petal length, petal width, and then species. Okay, so it's 5 different variables. And then so basically we get this, what we call the correlation matrix plot. And then we can also pinpoint down to the specific graph, let's say plot, iris, $sign. Just look at the species, right? That's the simplest variable because there's only 3 species. And let's see, what does it look like? All right, so then we click on it, we see this, right? Now 50 Setosa flowers, 50 versicolor flowers, and 50 virginica flowers. And also, let's say we want to take a look at the numerical variable, iris, $sign, and we do petal length. Any variable we like, we can just check it. Right, so let's run the code. And the third graph is what we see. That's what we need. So that the first block is for the Setosa, versicolor, and then virginica. Okay, 3 different blocks. Yeah. Now it looks like Virginica has the largest petal length, right? Compared to, and then verse color is a medium one, and then Setosa is the smallest one, the smallest petal length. Compare all three different species. Right, so now that's I'm putting one more, right? So plot Irish, and then let's look at the species. It's a capital letter for S, and Irish $sign petal width, or like pad. Yeah, let's try another variable, right? Petal width. Let's see what happens. Let's run it. The last one is so the RStudio will find the proper like graphers. Okay, so that's basically RStudio decided to create a box plot, right, to better compare all three different species. And if we look at the Setosa, there's a couple outliers here, and the distribution is it's skewed to the right, right? And it's not. You see, Q1 and the median are almost the same. That's identical Q1 and the median, right? So that's indicating the skewness, right? Skew to the right. And if you look at the verse color, again, it's just slightly skewed to the left because median is close to Q1. Right? It's not in the middle of those two, but it's closer to Q1. So it's a slight skew to the right. And then the Virginica, I think it's more like leaning towards the normal distribution. Okay, it's for the mirror image, right? Based on the median, it's close to normal distribution. Okay, so all three different species behave differently. And that's what we see. And also, let's say, build based on the last plot, just putting a little bit more arguments. Color, even different green colors, PCH, 19, main, title, Irish, title, oh, actually, yeah, so I'm going to change this instead of using species, I'll change it to, I think it's better to change to petal, both the numericals, right? Petal length, I change to petal length. So Irish petal length and Irish, meaning the horizontal axis is petal length, vertical axis petal width, because they both numerical. So the graph would be meaningful. Okay. Length versus petal width. And X lab is petal length. Y lab is petal width. I will do it. Now I'm going to run the code. Okay, let's see. Let's should put a quotation mark. I've got a quotation mark here. That's why it doesn't show. Now let's run it one more time. Yeah, so this is actually the updated graph. Okay, so this is Setosa, right? Verse color and then Virginica, right? Three different blocks. And petal length, petal width. So we if you look at we'll combine all three species, right? That's a positive correlation here as the petal length increases and the petal width also increases for all three different species, right? That's upward trend here. And this one has a stronger correlation, right? And also for Setosa and the verse color stronger. Virginica is slightly weaker. but overall, that's overall trend for all across all three different species. Right. Now let's take a look at creating a histogram using the ggplot, right? So far, we're just using the basic platform, basic plot options, like just plotting that, but we can use the more sophisticated package ggplot. That's what we did earlier. So let's create the histogram using the ggplot package, plot2 package. Now we're going to get a much better graph. So that again, get a coding block. And first of all, ggplot iris, right? Dataset aesthetics. This AES means aesthetics, meaning we put in arguments to make the graph more sophisticated. So X variable is going to be sepal length. And we just take a look at sepal length, this variable, and then we're going to create Geom histogram. We're going to generate a histogram for sepal length. And close that. And close the coding block. Let's take a look at the outputs. Okay. Look like this, right? And then this is very raw graph, you know, this, it's all branded. It's not nice, right? You see that the border is not separated. This is not good, right? Meaning by default, this it's not a very good graph, but we can put in a better graph. Let's see. So still, I'm gonna just use this. And in Geom histogram, I'm gonna put in color equal to red. And a fill, I'm gonna fill each rectangle box with a different color. Let's say purple. And then the bins, meaning number of the boxes, I'll give it 20 boxes. I will put in those three arguments, then the graph will become much better. You see, this is so much better graph. And based on this, we can also comment on the overall distribution here. We look at it, center is probably somewhere here, right? Between 5 and 6, maybe somewhere around, yeah, close to 6, right? Something like that. And this is actually a slight skew to the right, right? There's a skewness, slight skew to the right. Right. So we can adjust, we can put in a lot of different arguments to make a better graph right here. And let's say if you feel like, you know, 20 boxes is not good, you can change to, let's say, 24 boxes. Right, let's run it one more time. I see this is 24 boxes with 24 boxes. Just you can just adjust, right? Adjust the parameters to make it better graph. Okay. Now also I'm gonna show you guys how to create the frequency polygon here. So let's get another coding block. Still, we're gonna work on the same variable, ggplot, iris, dataset, aesthetics, open parentheses. We're going to focus on sepal length, same variable. I'm going to generate another graph called Geom frequency polygon. Right, this is a frequency polygon. And then the bins, we're going to use 20 boxes, 20 rectangle box. Color, just put in blue. Let's see how that goes. So then you click on run the code. And this is what the frequency polygon look like, right? And it's a lot like looks like time series plot, right? look at it, it's a continuous graph, right? You just connect all those different numbers, right? Connect those and then turn into a continuous graph. This is a frequency polygon. It depends on different data set, and sometimes it's better using one data set, one graph compared to the other, whichever serve the purpose. If you feel like this will serve your purpose of the delivering the information, right? Let's say you want to present this to your client, to your audience, and you feel like this graph will give you a better, layout, also the better, and you can deliver information in a better way than use this. So you have different kind of like different options. And also, let's create some of the scatter plots, right? Using ggplot as well. I'm gonna close all this. Wait. Scatter plot using ggplot2. Okay, got a coding block. Now we do this ggplot average data set, same data set. That is x is. So I'm going to specify both x variable and y variable, simple width. Also y variable, simple length. Close parentheses, close another one, and then plus geom point. So if you put on geom point, it's kind of like argument what kind of the graph we want. If you put in the points, meaning they will give us the scatter plot or scatter diagram. Then close it. Now let's run the code, see what happened here. Run it. Problem with the computing statics. Okay, probably some. Let me take a look at it. Missing something here. Statics x is simple width. Oh yeah, the dot, right? It's dot here. And dot here. Okay. So read through this description. If sometimes there's error in your code, read through this, you'll be able to debug your code here. So let me run it one more time. So now you see this is scatter plot. Okay. And then if you look at this, we actually see this one is pre-rendered, right? That means there's probably no meaningful, correlation between the simple width and simple length. So the correlation is pretty weak between these two variables. Now again, I'm gonna put in a little bit more argument, right? So I'm gonna recycle the previous code. Reuse the previous code. Then geom point here, I'm gonna put in a different color. So color here will be red. And I'm gonna put in the titles. So here labs x is simple width. Then y lab is a simple length. And also the title, also give a title here. Irises, purposes, title. Let's see how this one display. Okay, and I'll just run the code one more time. So we get simple length, simple width. Error in the labs. Okay, let me see. Maybe just yeah. So it's lowercase, no case here. Okay, so this is the updated graph. Okay, so I have a title here, x-axis, y-axis, and then also the main title. And also, let's say we want to separate all three different species, right? So we can just use this previous code. Now, in the first argument, after the y-axis, just type in color equal to species, right? So we're going to separate color based on species. So basically, you will split into three different species. And then under Geon point, I will get rid of this color here, no need. And we just assign RStudio will assign the color for Setosa, Versicolor, and then Virginica. Everything else should be okay. Yeah, everything else is okay. So let's run the code. Now, if you look at the third graph here, right? So the third graph is, so now the red one is Setosa, right? If you look into that, there's a correlation between the sepal width and sepal length. And the correlation is pretty strong, actually, right? It's very strong. You look at the Versicolor, it's weaker compared to Setosa, right? Because the points is the green ones are widely spread compared to the red ones. And then the blue ones is Virginica. So the third species. If you look at the Virginica, also, again, I think it's even weaker compared to the Versicolor, right? So the strength here is Setosa has the strongest correlation. Versicolor is ranking the middle, it's the middle, medium, and then the Virginica has the weakest, right? So has the least strongest correlation among all three different species. Okay. So basically, we see different kind of like pattern, right? Once we put in these arguments, we can distinguish into three different species and then adjust that accordingly. And also, I'll put this, let's say I just based on this previous code, I just gonna put in one more called Geon Smooth. Let me see if I put in that argument, if it helps us. Geon Smooth means we were asking the RStudio to smooth out the graph. Let's see if we get a better graph. Okay, so you see? And then look at the third graph here. Okay. I mean the last graph, right? And then we can see based on these patterns here, RStudio actually give us the kind of like a relationship using this this function here, right? So this one is closest to the linear, right? Linear correlation. As you can see, this one is weaker, and then the blue one, which is Virginica, is the least has the least correlation between the two variables, and definitely Setosa has the strongest, right? Almost like linear pattern. Also, if let's say we suspect there's a linear correlation, now based on, I'm gonna just reuse this, and under Geon Smooth, I put in we'll fit a linear model here, right? So from there, I put in arguments method equal to linear model. LM means linear model, so we will fit in a linear model for each species. SE equal false. So let's run the code one more time. No need this. Okay, that should do it. Now, as you can see, then it becomes a linear model. If you look at the last graph, you see linear model is fitting linear model, and I'm fitting linear model for each one of them. But again, Setosa has the strongest linear model among all three of them. And the Virginica has the weakest, right? Has the weak correlation between the two variables. All right. Yeah, so that's basically what I'm gonna do, right? So basically, based on what we learn, we actually come up with a different graphs, right? We learn box plot, we learn a scalar plot. We will study this in more details when we get to chapter 10, 11, 12, right? So also histogram. We did a lot of histogram and some basic graphs. And then you guys can take a look at this, and if you are interested in the coding, you can also build up the skills, on your own. But this is quick introduction to this coding language. Okay. Yeah. So any question? So on Monday, right, we'll finish chapter 6, and then we probably will start reviewing for midterm exam. Okay, on Monday, and I guess either Tuesday or Wednesday you will take probably Tuesday, right? We can finish review by Tuesday morning in the first hour. Then you have 2 hours to complete your midterm exam. Okay, on Tuesday, right? So that will be the tentative plan, right, for Monday, Tuesday. And Sebastian, you have a question?
Yeah, I was just wondering where the recordings for the classes are available.
Right. Recording, I usually post it. If you go back to our Brightspace course, I create a link here, right? You can always find it there, right? I probably will finish producing the video by maybe 3 or 4 p.m. And then you can just click on this Thursday Zoom meeting link. No, not that. It's last one. This is the link for our Thursday meetings. And I also have Thursday Zoom meeting videos. Okay, if you click on it, today's video will be posted here. It will say Zoom video on July 30th. Okay.
Okay, thank you, Professor.
Yeah, sure. Yeah. Any other questions? All right.
Professor, I'm
Mhm.
sorry, Professor, I have a question.
Sure. Yeah.
Yeah, did you say that an exam is coming Monday or Tuesday?
It's most likely Tuesday, right? We finished chapter 6 on Monday, and then we start review for the midterm on Monday. And then on
Yes.
Tuesday morning, first hour, we'll be able to finish all the reviews, and then you take the exam right after that.
Oh, all right. Yeah, got it.
Mhm.
Thank you.
Sure. And then Samantha, any questions?
Will the exam be in person or
Yeah, it's in
online?
person. Yes, no online, in person. And it's a paper exam. Right? You need
Okay.
to show our work on your exam. Yeah. And Stephen, any question?
Yeah, I was just wondering, if you already know like what the structure of the exam is gonna be, like
Structure?
multiple choice or like free response questions.
Yeah, if you look at your review from the Lumen, you should have a good idea, right? That's why we will do the review. If you look at go to the Lumen Home platform, Lumen Work channel, and most of the question will be short answers. So it's like what you did in your homework assignments, also in a midterm review. If you open a midterm review, that is midterm. And most of the question will look like this, right? And not much multiple choice, but something like this. Right? You will work on and then find the frequency, right? Frequency, and then construct the histogram. Okay, a lot like this. And then calculating mean, median, mode. Right? So this, the midterm review will be the very good sample, right, for the actual midterm. Yeah, Samantha.
Oh, sorry, I never turned down my hand.
Oh, okay, sure. So any other questions? But we will do a review on Monday, right? When we finish the chapter 6. Usually we'll finish the chapter 6 within the first couple hours, and the last hour we start reviewing for the midterm. We only need couple hours to finish the reviewing for the midterm. So on Tuesday, first hour we'll review, and then the second and the third hour you work on the actual midterm. Ayana.
This is more so a question for the other students, but by any chance has anyone in here made like a study group or anything for this class?
I'm not sure. Yeah. Anybody have
No,
information
but I
on
would
that?
like to know if you guys can add me if you guys have one.
Okay. Yeah, because I just wanted to know,
Mhm.
because if there's not, I mean, I know we're already like halfway through, but I'll make one and I can send
Yeah.
out an email for anyone who's interested in the link.
Yeah, that would be great, right? That would be great. You guys
Yeah.
can study together, right? Actually preparing for the midterm and finals.
Yeah.
And also, if you guys want to share your like Excel, like work with each other on the Excel project or homework, yeah, that'd be great. Okay.
All right, so I'll send
Yeah.
out a link to the class tonight.
Mhm.
Thank you, Professor.
Yeah, no problem. I'll see you guys Monday. Okay. Have a
Thank you,
nice weekend.
Professor.
Thank you, Professor.
Thank you. Have a good
No
weekend.
problem. Bye-bye.
Thank you, Professor.
No problem. Bye.